Hello everyone, this is How I Love Geometry. I'm Mr. Cao. Today's problem is from the book Introduction to Geometry. I just do uh, a little change. The problem says we begin with an equilateral triangle with the length 5. So this one. We divided each side into 3 segments. 1, 2, 3 of equal length and added an equilateral triangle to each side using the middle third as a base. So it means like this way, right? Added this equilateral triangle, a small each side. We then repeat this to get a third figure. So this one, it means like here, we can add this, and here, and here, and here, right? So the same thing on this 4 segment and this segment, and repeat this process. Continue this process forever. What is the area of the resulting figure? So, of course, this problem is forever. All of this like per for the forever problem, we have to find the pattern, how it changes, right? Find the pattern. It tells us this, the first figure, the second figure. This is the third, and then the fourth, fifth. So we should analyze this one to find the pattern. Let us say this one, let us say the first one. At first, I just say the area for first one is A. Finally, I will calculate how much for A, right? And the second one, the area is added. These 3 small equilateral triangle, right? So we know this small equilateral triangle is similar to the original one. So this side length is 1/3 of the original one. So the area of the small one will be the area ratio for the similar shape, right, is the square of the side ratio. This side is just 1/3 of this one. So the area is this 1/3 squared then times A, because original one, this area is A, and each one of this is like this one. And we have 1, 2, 3. So times 3. Now, the second figure's area is, original one is A plus this one, right? Here is A, and now this one is this. The area is this one. Now we will calculate this one. This one is just added like this, 1, 2, 3, 4. Just at the beginning, just for this side, and of course we have 3 of this side. That's A squared A times 3. That's this one. On the base of this one is added this. So we know that how to calculate this one, right? That's 1/3. Now is just 1/3 squared of this one area times this is just 1 of this one. So we got a square, 1/3, then squared, right? And how much we got? 1, 2, 3, 4. And how many sides? 1, 2, 3. So then times 3. And let us do some simplify for this one. So A plus 1/3, then squared A times 3 plus this 1/3 times 4th to the 4th power, right? To the 4th power, we can times 3 here, then times 4th to the 1st power. And for this one, we know we can times 4 to the 0 power, right? So we will find that the next one will be, for example, for this part, for this small part, it will becomes like here, 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 and here, added, right? It's another 4 more for this. So we can imagine the next one we can write like all of this, we just copy squared. Oh, I just use here, this color. A plus 1/3 squared times A times 3, and then 1/3 fourth power times 3 here, oh yeah, times 4 to 0th power, and yes, to the first power, 0 power, right? 3 times to the 4 to the first power, and plus yes, we forgot. Yeah, sorry, I forgot. Here is A, right? Here also A. Here is then A times 3 times. So 1/3 now is to the 6th power times A times 3, then times 4 to the 2nd power. And we can imagine if we just for next one, it will also like this one, to the 8th power times A times 3 times 4 to the 3rd power, right? Yes. We know this is an geometric sequence. This one, right? So when we, let us say the sum of this is S, we know the formula to find the sum of all of this geometric sequence. So S equals the first one. The first term is 1/9 times A times 3, then times 4, that's 1, right? And over 1 minus R. We know that R is 1/3 squared, then times 4. You see, here is 0 to the first, to the second, to the third, right? So that's 3 over 9A over 1 minus 4/9. So that's 3A over 9/5, right? So is 3/5 A. So yeah, 3/5 A. So now we can calculate the total area for this final total area. Or we can say final area is this A plus this one, 3/5 A. So that's 8/5 A. And we know A, we know the formula for the area of an equilateral triangle times the side length squared, so times 5 squared. So finally the area, the answer is 5/8 times this times 5 squared. Then we will got how much for this one? That's 2 and 5, and so we got 10 square root of 3. That's it. Okay, so the most important idea, we just find the pattern for all the problems about the forever infinitely. You should find the pattern, and for the geometry sequence regularly, it will converge finally, right? I mean the common ratio here, just like 4/9, here is 4/9. It must be less than 1, then it will converge. Then we can use the formula, find the final result. Okay. I hope you can enjoy it. I hope you enjoy it. Thank you. Meet you next problem.